The radioactivity of C14 isotope, half-life 6000 years, of a sample of wood from an ancient tomb was found to be one-fourth of the fresh sample the age of wood sample is. Before solving this question, we'll see the concept, that is carbon dating. Here C14 is formed in the upper atmosphere by the action of cosmic radiation on N14. By the action of cosmic radiation on N14. This C14 produced by the action of the cosmic radiation on N14 eventually converted into carbon dioxide. The C14 eventually converts into carbon dioxide and mixes with atmosphere, which in turn is incorporated into plants and trees by the process of photosynthesis. By the process of photosynthesis, and then finds a way into animals which eat plants. Finds a way into animals which eat animals because of the natural plant animal cycle. So an equilibrium is set up and all living matter contains the same small portions of C14 as it occurs in the atmosphere. Once a plant or animal dies, the uptake of carbon dioxide by it ceases and the level of C14 in the dead begins to fall due to the decay which C14 undergoes. When animal plant dies, the entry of C14 from atmosphere into it stops, but C14 in the dead species decays and its radioactivity decreases with age. Hence, by measuring the radioactivity of wood or animal remains and knowing the half-life of C14, their age can be determined by using this formula, where N0 is the activity of living plant, Nt is activity of fossil. Now if we see this problem, we can take that formula, that is lambda is equal to 2.303 by T log N0 by Nt. In place of lambda, we can take it as 0.693 by T half, because lambda is equal to 0.693 by T half. It is 2.303 by T log N0 by Nt. 0.693 by, where T half is 6000, is equal to 2.303 by T log N0. Consider that as initially in the activity of that C14 is 1 in the living plant. Now the remaining in that fossil, how much it is remaining, we can see in this problem. See, sample of wood from an ancient tomb was found to be one-fourth of the fresh sample. Fresh sample I am considering 1. So here how much is remaining? One-fourth is remaining. So from this, T is equal to 2.303 into 6000 by 0.693 log 4. So T is equal to 2.303 into 6000 into log 4 is 0.602 by 0.693. We'll get the value T is equal to 12,000 years. So for this given question, the answer is 12,000 years.